This program will incorporate many of the features discussed thus far in this chapter. It uses a while loop to accumulate amounts and then calculates and displays an average. It begins by declaring and initializing 4 variables. All these variables are initialized to 0, as you can see. This will allow us to perform the calculations necessary for this program. The user is prompted to enter a sales amount and a negative number to quit. This is necessary to allow a way for the loop to terminate normally. As you will observe, the loop is conditioned by the sales being greater than or equal to 0. That is, as long as the sales is greater than or equal to 0, the loop will continue. So therefore, when the user enters a negative number, this will cause this condition to be false, causing the while loop to terminate. Note that a while loop is being used, which means a pretest is in effect. This will allow for, if the user so chooses, to enter a negative number as the very first sales amount, and no calculations will take place, which are in the loop. Assuming the user enters a non-negative number, then this condition will be true, and the next statement that will be executed is a counter, which is keeping track of the number of sales. This is necessary to allow us to create an average at the end of the process. The next calculation is to accumulate the sales into the variable total sales. Notice the pattern. Anytime you want to accumulate is to create a variable such as total sales and set it equal to itself, total sales, plus the variable, in this case sales, that we're trying to accumulate. The same pattern is created when you're trying to count, that is, a variable set equal to itself plus 1. The user is then prompted to enter another amount or negative number within the loop. Notice the braces being used to indicate the contents of the loop. This loop will continue as long as the user enters a non-negative number. When the user does enter a negative number, this condition is no longer true, and then the control is brought down to the bottom of the loop, where in this case the average sale is calculated, which is the total sales divided by the number of sales, which is our counter. And then the average sales is simply displayed in the cout statement. Let's compile and execute this program to observe its run. If I enter $1,000 as a sales amount, and then a sales amount of $2,000, followed by $3,000, and then a negative number to quit. Any negative number would do. It correctly calculates the average sales of 2,000. Since I entered 1, 2, and 3,000 for a total of 6,000, and there were 3 entries, therefore 6,000 was divided by 3, giving an average of 2,000. So the program does indeed work, and it does perform all the calculations necessary. Recall that counters and accumulators should be initialized with a beginning value. In this case, we initialized each of the variables when we declared them. Although most counters and accumulators initialize to 0, you can in fact initialize them to any value that the algorithm demands. Notice that the prompt tells the user to enter a negative number when he or she is finished entering sales amounts. Values that are used to end loops are referred to as sentinel values. In the current program, the sentinel value is any negative number. The sentinel value should be one that is easily distinguishable from the valid data recognized by the program. In this program, for example, a negative number is used as the sentinel value because the sales amount cannot be less than 0. You would not want to make the sentinel value a valid sales amount, such as 2,000. Also note that there are 2 sets of prompts, above the loop and also within the loop, to prompt the user to enter a sales amount. This is necessary due to this fact. Recall that after the while loop instructions are processed, the program returns to the beginning of the loop, not outside the loop. Because the first cout and C instructions are located before the while clause, the program will never return to those instructions once the loop begins. In other words, the cout and C instructions located above the loop get only the first sales amount from the user. The cout and C instructions located within the loop get each of the remaining sales amounts, if any, from the user. If you forget to enter the second set of input instructions, the user will not be able to enter either another sales amount or, more importantly, the sentinel value that stops the loop. Until the sentinel value is entered, the loop will continue processing its instructions indefinitely. This type of loop is referred to as an endless loop, and which obviously is something you want to avoid. This program, of course, can be written many different ways. In fact, you could write this program using the do-while loop as opposed to the while loop. You could also use a for loop, since a numeric amount, the sales amount, is being used as the key field that is controlling the processing of the loop. You may want to experiment with rewriting this program, which is Demo 24, using the alternative looping techniques that we've discussed.